Hello everyone, welcome to my YouTube lecture on HDL programming using Verilog. So in the last class, we studied about the structured procedures, namely initial block and always block, and we could understand it using simulations in Xilinx tool. Today we are learning about procedural assignments, especially we have blocking and non-blocking statements, assignment statements. So before we go with blocking and non-blocking, let us understand what does the procedural assignments means. The usage or the syntax goes like this: left hand side value equal to expression. Only thing is we are not using assign here as in the case of data flow style of modeling. In behavioral style of modeling, we directly start writing the left hand side equal to right hand side expression, which are in turn enclosed in any of the sequential block that we discussed in previous session, that is always or initial. The left hand side of the procedural assignment, that is L value, can be one of the following. So left hand side can be a register, integer, real or time register variable, or a memory element, or it might be a bit select of these variables like address of 0, 1 bit, a part select of these variable, that is address 31 down to 16, it's around 15 bits or 16 bits, a concatenation of any of the above. So these all can be on the left hand side. The right hand side expression can be any expression that evaluates to a value. There are two types of procedural assignment statements. One is blocking and the other is non-blocking. Very important concept. Let us understand what's the meaning of blocking assignment. The blocking assignment statements are executed in the order they are specified in the sequential block. So these are executed in the order in the sequential block, that is initial or always block. The blocking assignment will not block execution of six statements that follow in parallel blocks. Parallel block means think that we have 2 to 3 always blocks or 2 to 3 initial blocks. As we have understood that the initial and always blocks are independent. So hence those things are called as parallel blocks. So one statement in one of the always block is independent of the other statement in the other always block. So if it is with a respect of one of the always block or one of the initial block, then this blocking assignment blocks only statements within that particular sequential block or particular initial or always block. So more of this sequential and parallel blocks will be explained later in the coming sessions. So the blocking assignment uses the equal to operator to specify blocking assignments. The behavior in the particular block is sequential in a begin and end of the block. Inside begin and end, whatever you write in a sequential block, it will execute sequentially. Let us make the understanding much more clearer by taking up one example. Here I have taken an example. I am declaring a three variables of register type x, y, z and a 16-bit vector reg underscore a and reg underscore b. Integer count. You know that integer, whenever we declare it as integer, so it is as good as declaring a register variable of 32 bits. Initial, for initial block, I am having only one initial block. Initial, begin and end encloses all the sequential statements. Sequential statement means in the initial block x equal to 0 will be executed first and followed by y is equal to 1 and followed by xz equal to 1 and followed by count equal to 0 and followed by so and so and so. So it is sequential execution inside the sequential block. So x equal to 0, y equal to 1 and z equal to 1 will start executing at 0 simulation time and even count equal to 0. And reg underscore a gets 0, reg underscore b is equal to reg underscore a. So all these executes at sequential at simulation time 0. And after 15 time units, reg underscore a of 2, this is single bit, the third from least significant bit of register reg underscore a will be assigned with 1, and after 10 time units, 15 plus 10, 25 time units, reg underscore b, this vector receives the concatenation of x comma y comma z. And after 25 time units, count is equal to count plus 1 because it executes sequentially. So 0 till here 0 plus 15 plus 10 to 15, that is plus 25. After plus 25, count will be incremented. So what happens here? So here all statements till x equal to 0 till reg underscore b assigned with reg underscore a, that is x equal to 0 till reg underscore b is equal to reg underscore a, all these statements will execute at 0 time. Statement reg underscore a of 2, this statement will be assigned with 1 only after 15 time units. And statement reg underscore b 15 down to 13, it will be assigned with x comma y comma z concatenation at after 15 plus 10, that is 25 time units, that is written here. And count will be incremented after 25 time units. Since there is a delay of 15 and 10 time units in the preceding statements, count will be incremented only after 25 time units. So let us check the same thing using a Xilinx tool. So let me copy the code for blocking statement. I just copy it here. So I'm copying it. So reg equal to, okay, reg of x comma y comma z, everything is same. One initial block I had explained. The other initial block is a system task. It is just to keep us alert or keep us more informed about how the statements have got executed. Monitor, it monitors whenever there is a change in the value of the x, y, z, reg underscore a, reg underscore b. It will display it in the console. Let us check. Save it. Simulate. So here, once you simulate it, I just zoom to fit and I just maximize it to just check here what's happening. I minimize it for your understanding. You can check at 10 time units. At 10 time units, your reg underscore a is being changed. Reg underscore a of 2 is receiving value 1. So that is what we studied here. Reg underscore a of 2 is receiving 1 at time 15. At time 15 it is changing. And at time 25, reg underscore b is changing its value. So x, y, z are being assigned with most significant bit 0, 1, 1, 0, 1, 1. And then at the last, count is getting incremented at 20 after 25 time minutes. At after 25 time minutes, your count is incrementing to 1. You can see the significant bit has been incremented to 1. So this is how the simulation takes place. And one more thing what I want you to observe is here this delay has been mentioned at the first stage before the assignment starts, whereas in Xilinx I have just used the other kind of delay. So these timing controls we'll be discussing later, but you can see I have mentioned it #15 and #10 after the assignment operator. There is one difference between these two things. If I assign the delay here, it is called as regular delay control, and if I assign here, it is called as intra assignment delay. If you write it here or here, it does not make any difference in blocking statements, but it makes certainly a lot of difference in non-blocking statements. That's why I keep it here in blocking as well as non-blocking also. I'll keep it here. Minor change in non-blocking, we'll just change it whenever it is needed after explanation. So next, this is non-blocking assignment. So non-blocking assignments allow scheduling of assignments without blocking execution of the statement that follows in the sequential block. It does not block any of the statement which are subsequently placed. So like otherwise in blocking statements, it blocks the statements that are followed by it in the same sequential block. It does not, but in non-blocking assignment statement, it does not block any of the statements. And the operator used for non-blocking assignment is less than or equal to. So less than or equal to operator is used for mentioning non-blocking assignments. Now there will be a confusion that this same operator is interpreted as a relational operator in an expression and as an assignment operator in the context of non-blocking assignments. So if you use it as assignment operator, then it will understand it as non-blocking assignment. If you use it in condition writing, then it will be treated as a relational operator. It is worth noting the point. Now again the example is same as before, only changes Here in these two statements, this statement and this statement, I have changed the blocking statement assignment to the non-blocking assignment. Rest everything is same, equal to equal, everything is same. Only these two things I have changed it to non-blocking assignment rather than blocking assignment. So with these two things, what max difference that can happen? You just check here. Initially from x equal to 0 till reg underscore b is equal to reg underscore a. Till here at 0 simulation time it will execute, and after and reg underscore a of 2 will receive 1. It is executed after 15 time units, and reg underscore b 15 down to 0 is scheduled to execute after time units. Here is a difference. So initially in blocking assignments, what we studied is after 15 time units this one will be assigned here, and after 15 plus 10 25 time units this xyz will be assigned to this one. That is what we studied in blocking assignments, but in non-blocking assignment it does not happen. So it will not block at all. So 15 time units, one will be assigned to reg underscore a of 2. At 10 time units itself, x comma y comma z concatenation will be assigned to the most significant bit of reg underscore b. Means this statement is not blocking this statement. These two statements are executed at a time. So this is assigned at 10 time units only, and this will be assigned at 15 time units. So this difference we shall observe in the simulation. So I just changed these two statements. You can check less than or equal to. This is non-blocking assignments. Now we'll see what major difference it can cause. So count incremented after 25 time units in blocking assignments, whereas in non-blocking assignment it does not block at all. Count should increment at 0 time itself. Let us check whether it is happening or not. I am simulating it. So it has opened now. I just zoom to fit and then I go on maximizing it. You can check here. Reg underscore a after 15 time units it is assigning reg of a underscore of 2 will be assigned with 1. Reg of b is been changing its value. It is getting x equal to 0, y equal to 1 and z equal to 1 in most significant bit at 10 time units only, not after 15 plus 10 25 as in case of blocking, but it is non-blocking assignment, hence it is executing at the same time. And you can see the count is incrementing at 0 time units itself. You can see here count has incremented at 0 time itself. You please remember this. Let me show the blocking assignment once again. In blocking assignment, count will be incremented only after 25 time minutes. You can check only after 25 minutes in blocking, whereas it is not waiting here at 0 simulation time itself. It is changing, and this reg underscore b will execute after 25 time minutes. You can just check. This is just to avoid confusion, because this is one of the complicated concept which most of the people fail to understand. So that's why I'm repeating. Now, after 25 time units, count will be incremented. You can check that particular concept. So here you can see that after 25 time units, count is getting incremented, and reg underscore b also is getting assigned after 25 time units, and this as usual. So this is a main difference between non-blocking assignment and blocking assignments. Hope it is much more clear with a simulator. So here non-blocking assignment and blocking assignment, there is quite a number of differences that we can observe. And what are those differences? We will note it down. You also try to note it down, or else let me just write it at the end while writing the summary. And here are some applications of non-blocking assignments. Let me go quickly. So application of non-blocking assignments, I have always block, pause edge of clock. So I have 3 assignments, non-blocking assignments here. Reg 1 is assigned with in1 after 1 time units, and it is not timing, it is rather event. At negative edge of the clock, this will be assigned to reg 2. After 1 time units, reg will be assigned to reg 3. So what happens here? So in non-blocking assignments, first read operations of all RHS expressions happens. RHS expression will complete its evaluation process. This will complete its evaluation, this also complete its evaluation, this also complete its evaluation. But while writing, LHS will be updated only after one time unit here, and this also updated at the same time, and this will be updated at certain event, that is negative edge of the clock after positive edge, very next positive edge. So hence the final values reg1, reg2 and reg3 are not dependent on the order in which the assignments are proposed. Very important application. So one more application which will definitely convince you in a much better way. Here I have used the same statements, only changes. Here I'm using blocking state assignment. Here I'm using non-blocking assignment. What actually I'm doing is I'm having two always block, and it will execute only when there is a pause edge of the clock. A is assigned with B, B is assigned with A, and these are parallel blocks, parallel execution. Hence both start at 0 simulation time. B tries to assign itself to A, but A tries to assign itself to B. So which one will happen here? So such a case is called as race condition. Whenever there is a race condition, values of the resistors A and B will not be swapped. Instead, both resistors will get the same value. So this is a problem with the blocking assignments, because it is a race condition. We cannot determine which will get assigned with what value. Either it is again a simulator dependent. If either B will be assigned, B will be retaining its value, or A will be retaining its value, but definitely it will not does a swapping operation. Whereas in non-blocking assignments, it eliminates the race condition. What happens here is separate read and write operations ensure that the values of resistors A and B are swapped correctly, regardless of the order in which the write operations are performed. So here swapping operations is performed. Why? Because, let me go in detail. So whenever we use a non-blocking assignments, it is treated as some temporary variable will be assigned while read operation. First read operation happens, means in read operation what we are doing, B is assigned with A and A is assigned with B. So this operation, A is assigned with some temporary variable A, it will be stored there. B is assigned with temporary variable B and it will be stored there. And when A's value assignment starts, temporary value of B is assigned to A, temporary value of A is assigned to B. So the swapping happens. So this will be internally happening whenever non-blocking assignments happens, takes care. So typical application of non-blocking assignments include pipeline modeling and modeling of several mutually exclusive data transfers. On the other side, non-blocking assignments can potentially cause a degradation in the simulator performance and increase in memory usage. So you should carefully use non-blocking assignments. You're not supposed to use non-blocking assignments everywhere, because it degrades the performance of the simulator. Let us see whether I have a code of the swapping so that I can show it to you. It's okay. Take it as an assignment. You can just try this code, this code as well as this code, and see what will be the value of A and B, A in blocking assignment and in non-blocking assignment. Which one will swap and which will not swap? You need to just comment it in the comment box. So before we proceed with the next timing control topic, we shall just summarize. So in the summary, we just see what are the main differences between the blocking and non-blocking. So we studied about blocking assignments and non-blocking assignments. We shall just learn about the differences that we have now. So this is blocking assignment, non-blocking assignment. These are the differences, very important part. So first difference is the assignment operator. Here equal to operator is used. Here less than or equal to operator is used. Second difference, there is no temporary variable declaration by the simulator. No temporary variable declaration by the simulator. Here temporary variable will be declared. Variable is declared. Third difference, It blocks subsequent statements in a sequential block. Whereas non-blocking does not block the subsequent statements. Third difference. Fourth difference. Here, let me write the fourth difference. So each statement, whenever non-blocking assignment is used, read and write operations are performed two steps. It takes two steps for performing. First, reading of all RHS and then writing happens. Whereas here, single step. No separate read and write. Fifth difference. This might result in race condition in few cases. Like I just gave an example of swap operation. Whereas it eliminates race condition. Then last difference, it usually does not degrades simulator performance. Whereas this non-blocking can potentially causes degradation of simulator. So these are the differences of blocking and non-blocking statements. And if you have any doubts or any queries regarding this, you can just comment in the comment box. Thank you.